Hey guys, what's up? Welcome to another episode of the Real Hacker Hour podcast. This is basically where I just do the work that I normally do on side projects and stuff like that. It's just I hit the record button before I do it. Right now I'm kind of working on a fun little project that's only going to last probably a few weeks. Basically, I'm just, for the meme of it, going through just random servers on the repos on GitHub, fuzzing it, and if I find a bug, I'm just going to submit a pull request to fix it, or just open up an issue. Basically, just let the devs know that, hey, this is a bug. So here, this is a DNS server, simple DNS, and I think I found a bug. The fuzzer's able to crash it. So I'm just going to effectively figure out what the bug is and what I can potentially do with it. Cool. So we run this, and here's this fuzzer is just, it's off. It's a fuzzer I made a while ago. And we run it. Wait a second, and it appears that, I'm going to stop this. It appears that we got a crash, or particularly stack check failed. That function was called stack smashing detected, so probably have a stack buffer overflow. Appears to be in the decode domain name function, so let's take a look at that. This right here is the source code to the server. This is the source code to a fuzzer that I made. But yeah, let's just go ahead and search for that. Cool, so here is the function. Let's take a quick look at it. It takes a single argument, which is a uint8 buffer, which gets converted over to here, and then it appears to iterate through it. Wow, that does not equal 0, so basically looks like it just iterates through until it reaches nullby. But one thing that just easily comes to mind is this memcopy value. We can see here that it okay, so taking a step back, what I see here, there's a memcopy call with a length to a buffer and name, which name is a fixed buffer on the stack. And we see that length is coming from buff, which if buffer is user controlled input, that means we control the length, which means we control how much this memcopy writes into a fixed buffer, and there's no check on that, so I'm kind of thinking that's what the bug is, but let's confirm that. How can we do so? Well, we could employ the use of replay. Let's see. Trying to think, how can we do this? We could set a breakpoint for memcopy. Actually, let's set a breakpoint for decoded domain name and see what the input buffer is. That'd probably be the best way to do this. Let's continue run this. Break at decode domain name. So we set breakpoints. What is? Let's also get Wireshark going. Let's bring that up to this screen. Run that again. Restart this. Let's run it until the breakpoint gets hit. Okay, the breakpoint got hit. Okay, cool. Looking at the RDI register, appears that this is the... Let's take a look at this. Appears that this is the data sent. Let's see if we can't find a packet with that. Data. Let's take a look, actually. I'm trying to right now correlate the data captured by Wireshark 2 here to see it. However, C3... This could just be, very well just be me being blind, but I'm not seeing it. You know what? Probably a much better solution just to where is the decode domain name called, which is called from here buffer decode message. So it just takes that and passes that to it. Buffer. Okay, so it does appear just to be the straight the output that it gets from receive from. So, let's take one final look. Okay, cool. Not able. Why can't I? I'm just gonna take. This is really driving me crazy. Why can't I? Let's. Let's just view the entirety of this. Hang on, I'm going to pause the stream for a second. Okay, so yeah, I'm pretty sure that memcopy call is where the bug is, but just to confirm it, I'm just going to quickly write effectively just a Python script to send it a packet. That way that I believe will crash it, and that way it should help confirm it. I'm going to pause the stream again until that is done. Okay, I'm back. Here is... I had to go reread the DNS RFC real quick. But yeah, here's the quick Python script I wrote up that just sends a central DNS query, header, question, the packet composed of both. And when we go ahead and run the POC, we see that we do indeed hit decode domain name. Now, one thing, the RDI register has a pointer to the start of the question. We see here it's 06 followed by some ASCII. When we actually look at it, we see it's 06 github 03 com, which is the same thing as our queue name. And we're going to go ahead, let's code name. Let's go ahead, right here, continue. Let's go ahead and look at the arguments. We see then the RDX register is 6, which happens to coincide with the 6 value from our queue name. Now, let's try changing this to something. Let's try 7. Let me run this, hang on a second. Okay, I'm back, yeah. So we changed it to 7, let's try running it. We still have the breakpoints that we do. And we see that changed to 7. Cool. 7. Okay, you see that's called multiple times. Now, let's try changing this to something super large. The value, what is the value? Value is 256. Let's try setting it to that. And that, and seeing if that causes a crash. It does, cool. Now, let's just confirm it by that is indeed causing the crash by... What I'm going to do is I'm going to try and replace the GitHub and the com with F times a bunch of Fs. That way I could actually see the return address before and after the memcopy call. And if it got changed to FFFF, then that's basically 100% proof that this memcopy call is a Stack Overflow. Pretty sure it is already, but just to be sure. So, go here. This first call, FF, I don't believe this will overflow it. Reason for it being is if you look on here, length equals buff I. So the length can only be represented by a 1 byte integer. So the max value of that OXFF at 255, which the name is a 256 byte. So the first time we go ahead and try to have the first octet, we can't overflow it then. However, what happens is where we're writing to in the name buffer gets incremented by length. So what that means is the first time it can have 255. So we write 2 byte 0, moves us all the way up to basically the last byte of the buffer, and then the second time it goes right through, that's when the overflow actually happens. And just to make sure, one second. Okay, yeah, sorry about that. Frame. So we see RAP is actually, wait, no, let's continue to the second breakpoint. So we're here, we're at the memcopy call. You see it's the first octet in full frame. Let's check this. Okay, looks like a typical return address. Let's go step into that. Finish. Still a typical return address, so let's hit this again. Frame. Let's just make sure that, yeah, it's still that. And then we step into this. Finish. OX6. And when we do this. Okay, cool. So yeah, we can clearly see that this is indeed this is indeed a buffer overflow bug from the memcopy call. Cool. So the question is, how do we patch it out? So you can submit a pull request, and let's look on here. So taking a look at here, what is the bug? The bug is that while in any one iteration we cannot overflow the name, the issue comes from the fact that J, which moves up the index in it, after you move it at least like 1 byte forward, then it becomes within the range within a single 1 byte value. You can overflow it. So let's try writing a decode name. What is return? Stirred up name. So we would write a check like if, okay, if if J plus length is greater than or equal to 256, then have oh hey, overflow issue. We have the code. I'm not sure quite what the overflow issue would be. The reason for it being is I'm not sure what this decode name is called from. Let's decode. We could have it just return a single value. Do a check. Decode message. Return 0. What is this called? Print query. Go query. So if this does not equal to 0, so if it is equal to 0, move on. If not, so if we get this decode message function to return a 0, it should just loop forward and ignore it. How can we do that? We can implement a check that if this return value is a specified enum, then return 0. Actually, it does not equal to 0. Oh, so if it returns 0, then it won't continue, and the rest of this function will execute. So we just get this to return a non-zero value, even though it can only return 0. So we have if qname is equal to overflow name return -1. So something like that. Probably want to establish enums with it. So then we need to look at this. This returns a char pointer. So let's return. I'm probably going to want to establish enums, but let's do just /0. Let's do null 1, something like that. Well, I'm just going to have that there. Now, let's see, does this actually compile? Make equals... Actually, I'm going to define this. There has to be defined buff size. So we define that. And let's go through. Go domain name. Okay, cool. Let's return this value instead. Character constant too large for its type. Let's try to get rid of some of these errors. Character constant. Wait, oh, I probably... This should be... Oh, this is what happens when you don't code C for a while. You make stupid mistakes. Comparison stringlet or results in char pointer. Try to get rid of them. Hang on a second, let's look at the structure for this. Char pointer. Let's cast this as a char pointer. Cool, compiles, no errors. Let's also take a look at this here. Code. Okay. Now let's try running this. So it's recompiled. So the POC does not appear to work anymore. However, let's go over to our fuzzer. Just type in arguments to it. Okay, it does appear to work, and does not look like it's crashing, so it looks like the patch that we had is indeed working. Okay, so we saw that it appears that the server is clearly able to support queries still. Does not appear to be crashing. I'm not sure running the POC one last time even though we ran it, just to be 100% sure. Making a lot of typos here. Yep. So the patch rework appears to be successful in mitigating that bug. I'm going to go ahead and make the pull request now. Cool. Okay. But yeah, this is where I'm gonna cut it off. So we found the bug with a fuzzer. Identified there was a memcopy call within the decode domain name function. We're able to identify what caused the bug. We're able to identify the mitigation, write the code for it, and actually test it and verify that was. Cool. I'm going to end it off here. See you guys later.